Hello students, we are studying this chapter laws of motion from 11th physics, and in today's video we are going to study collision in two dimensions, that is non-head-on collision. When two bodies moving along different directions collide on each other, then that type of collision is called as non-head-on collision. On the other hand, when two bodies moving along same straight line path, either in same direction or in opposite direction, and when they collide on each other, that type of collision is called as head-on collision. In previous videos we have derived these expressions. This equation 1 gives velocity of first body after collision in case of elastic head-on collision. Equation 2 gives velocity of second body after collision in elastic head-on collision, and equation 3 is formula for coefficient of restitution for elastic head-on collision. If we know masses of two bodies and their initial velocities, then their final velocities can be determined by using these two equations. Similarly, if their initial and final velocities are known, coefficient of restitution can be determined by using this equation number 3. But these relations cannot be used for non-head-on collision. So in today's video, we are going to derive such type of equations for non-head-on collision, which will be helpful to determine velocities of the bodies after collision. Consider one such non-head-on collision. Suppose these two bodies of different masses m1 and m2 collide on each other, and this is the point of contact when these two bodies collide on each other. This line, vertical line passing through this point of contact, is called as common tangent, while this line which is perpendicular to this common tangent is called as line of impact. Suppose the first body was moving along this path shown by this arrow with initial velocity of u1, and that initial velocity, direction of initial velocity, makes an angle of alpha 1 with this line of impact. After colliding on second body of mass m2, that first body moves along this path, this different path, changes its direction due to collision, and velocity after collision is v1. Suppose v1 is final velocity of first body after collision, and suppose this final velocity is a vector quantity, therefore it has both magnitude as well as direction. That final velocity makes an angle of beta 1 with this line of impact. Similarly, second body having mass m2 is moving along this direction before collision. This u1 and u2 are velocities before collision, and these arrows, this arrow of u1 and u2 represent their directions of motion before collision. u2 is initial velocity of second body before collision, and angle made by this velocity vector u2 with this line of impact is alpha 2. After collision, that body, second body, moves along different direction shown by this arrow, and its velocity after collision is suppose v2, and let this v2 makes an angle of beta 2 with this line of impact. Now we will simplify this diagram. We will draw their free body diagrams, FBDs, where vectors will be shown. Only vectors will be shown. We know any vector can be resolved into two perpendicular components. Similarly, here also we will resolve all these four vectors u1, v1, u2, v2 into their rectangular components. u1 has two rectangular components. One is vertically downward and second is horizontally towards right. See, both these components are perpendicular to each other. They are called as rectangular components. One component is cosine component and second is sine component. This is u1 cos alpha 1. Always remember, when we resolve any vector into two perpendicular components, the component which is adjacent to the angle is cosine component and remaining component is sine component. No need to show this vector u1 now. because we have resolved it into two perpendicular components. आपण u1 दोन components मध्ये रिझॉल्व्ह केलेला असल्यामुळं तो वेक्टर u1 दाखवायची गरज नाही, कारण u1 cos अल्फा 1 आणि u1 sin अल्फा 1 हे दोन्ही वेक्टर्स त्या u1 चं काम करतात. त्यामुळे u1 दाखवायची गरज नाही, तो अँगल अल्फा 1 सुद्धा दाखवायची आवश्यकता नाही. सिमिलरली we can resolve this vector v1 into two perpendicular components. One is v1 sin beta 1 and second is v1 cos beta 1, because here angle is beta 1. Initially that angle was alpha 1. As v1 add through this two components v1 cos beta 1 and v1 sin beta 1, there is no need to show this vector v1 दाखवण्याची आवश्यकता नाही, तो अँगल सुद्धा दाखवण्याची आवश्यकता नाही. So this is free body diagram for first body where only vectors are shown. Similarly, we can draw free body diagram for this second body. This u2 has two components. One is u2 sin alpha 2 and second is u2 cos alpha 2. Similarly, this v2 has two components. One is v2 cos beta 2 and second is v2 sin beta 2. इथं v2 आणि beta 2 ते अँगल्स दाखवायची आवश्यकता नाही. Now, according to law of conservation of linear momentum along the line of impact, we know law of conservation of momentum means total momentum before collision equal to total momentum after collision. We will get this relation. Total momentum before collision means momentum of first body before collision plus momentum of second body before collision. We know momentum is mass into velocity. For first body, mass is m1 and initial velocity is u1 cos alpha 1 before collision. And we are taking components along line of impact, means horizontal component. So horizontal component is u1 cos alpha 1, m1 into u1 cos alpha 1. This is initial component, initial velocity along this line of impact before collision. Therefore, mass into initial velocity is initial momentum before collision for first body plus initial momentum of second body before collision, which is m2, mass of second body into initial velocity of second body along horizontal direction, equal to total momentum after collision, means momentum of first body after collision, which is product of mass into velocity, m1 v1 cos beta 1. We are taking only horizontal components, so horizontal component for first body is v1 cos beta 1. Therefore, this product m1 v1 cos beta 1, which is momentum, final momentum of first body after collision along horizontal direction, plus final momentum of second body after collision, which is product of mass of second body m2, that is m2, into velocity of second body after collision along horizontal direction, which is v2 cos beta 2. This is v2 cos beta 2. This is equation number 1. हे इक्वेशन 1 झालं. अशाच पद्धतीने आणखी एक इक्वेशन आपल्याला काढायचं आहे आणि हे इक्वेशन्स जे आपण डिराईव्ह करणार आहोत त्यांचा एकत्रितपणे उपयोग करून आपल्याला त्यांच्या व्हेलॉसिटीज काढता येतील. As there are no forces acting along the line of tangent, there is no change in momenta along the line of tangent. बघा, न्यूटन सेकंड लॉ तुम्हाला माहीत आहे, ज्या ठिकाणी फोर्स असतं त्याच ठिकाणी मोमेंटम चेंज होतं आणि मोमेंटम चेंज त्याच डायरेक्शनला होतं ज्या डायरेक्शनला फोर्स ॲक्ट होतं. जेव्हा ह्या दोन बॉडीज अशा वेगळ्या डायरेक्शनला आलेल्या आहेत आणि त्या एकमेकांवरती कोलाईड होतात, तेव्हा फोर्स हे लाईन ऑफ इम्पॅक्टच्या दिशेला आहे. तो कॉम्पोनंट फक्त त्या ठिकाणी आहे जो व्हर्टिकल टँजंटला त्या डायरेक्शनला फोर्स नसतं, त्यामुळे टँजन्शियल म्हणजे व्हर्टिकल डायरेक्शनला मोमेंटम चेंज होणार नाही. म्हणजे पहिल्या बॉडीचं जे मोमेंटम व्हर्टिकल डायरेक्शनला होतं, हॉरिझॉन्टल डायरेक्शनचं चेंज झालं, परंतु व्हर्टिकल डायरेक्शनचं जे मोमेंटम होतं ते बदलणार नाही. फॉर फर्स्ट बॉडी, momentum before collision along horizontal direction is m1 into u1 sin alpha 1, because we know momentum is a product of mass and velocity. Mass of first body is m1 and initial velocity before collision along vertical direction is u1 sin alpha 1. and momentum of first body after collision is mass m1. Mass doesn't change during collision. Mass m1 into velocity, final velocity of first body after collision along vertical direction is v1 sine beta 1. So initial momentum m1 u1 sine alpha 1, final momentum m1 v1 sine beta 1. There is no change in momentum. Therefore, initial momentum along vertical direction before collision equal to final momentum after collision, and that is along vertical direction. Therefore, we can write m1 u1 sin alpha 1, product of mass and initial velocity along vertical direction, which is u1 sin alpha 1, see here, equal to final momentum, product of mass of first body m1 into this vertical velocity after collision v1 sin beta 1. This is equation number 2. Similarly, for second body also, initial momentum before collision is m2 u2 sin alpha 2 is equal to m2 v2 sin beta 2. This is equation number 3. म्हणजे यापूर्वी डिराईव्ह केलेलं ते इक्वेशन 1, हे इक्वेशन 2 आणि इक्वेशन 3 ह्या तिन्हीचा एकत्रितपणे उपयोग करून आपण कोलिजन नंतरच्या त्यांच्या फायनल व्हेलॉसिटीज v1 v2 काढू शकतो. फक्त त्यांचे मासेस आपल्याला माहिती पाहिजे, m1 m2, त्यांच्या इनिशियल व्हेलॉसिटीज u1 u2 माहीत पाहिजे, आणि हे अँगल्स अल्फा 1 बीटा 1 अल्फा 2 बीटा 2 हे माहीत असले पाहिजे आपल्याला, तर ते काढता येऊ शकतं. जस्ट लाईक वी हॅव सीन एक्सप्रेशन फॉर कोइफिशियंट ऑफ रेस्टिट्यूशन for perfectly elastic head-on collision. Here also we can write formula for coefficient of restitution. We know that coefficient of restitution is given by this formula, equation number 3, E equal to minus v1 minus v2 upon u1 minus u2. Relative velocity after collision. Relative velocity means difference between two velocities after collision. After collision म्हणजे ह्या कोलिजनच्या आफ्टर कोलिजन मीन्स दिस सिच्युएशन. रिलेटिव्ह व्हेलॉसिटी म्हणजे त्या व्हेलॉसिटी मधला डिफरन्स v1 मायनस v2 अपॉन रिलेटिव्ह व्हेलॉसिटीज बिफोर कोलिजन, म्हणजे बिफोर कोलिजनची ही सिच्युएशन आहे. इनिशियल व्हेलॉसिटी मधला डिफरन्स u1 मायनस u2. हा असतो कोइफिशियंट ऑफ रेस्टिट्यूशनचा फॉर्म्युला, परंतु हा आपण हेड ऑन इलास्टिक कोलिजनसाठी घेतो, हेड ऑन कोलिजनसाठी घेतो. आता ते इनइलास्टिक असेल तर ईची व्हॅल्यू वेगळी असते आपल्याला माहीत आहे, परंतु हाच फॉर्म्युला आपल्याला जर नॉन हेड ऑन कोलिजनसाठी वापरायचा असेल तर तो फॉर्म्युला अशा पद्धतीने होईल, ई इक्वल टू मायनस अँड दिस रेशो. कारण रिलेटिव्ह व्हेलॉसिटी आफ्टर कोलिजन काय आहे, तर आफ्टर कोलिजन दुसऱ्या बॉडीची व्हेलॉसिटी आहे v2 कॉस बीटा 2 आणि पहिल्या बॉडीची आहे v1 कॉस बीटा 1, त्या दोघांमधला डिफरन्स, त्याला डिवायडेड बाय केलं इनिशियल व्हेलॉसिटीज. आता दुसऱ्या बॉडीची इनिशियल व्हेलॉसिटी काय आहे u2 कॉस अल्फा 2 हॉरिझॉन्टल डायरेक्शनला, आणि पहिल्या बॉडीची इनिशियल व्हेलॉसिटी काय आहे बिफोर कोलिजन u1 कॉस अल्फा 1, त्यांचा डिफरन्स आणि त्यानंतर यांचा रेशो. हे इक्वेशन आपल्याला नंतर हे निगेटिव्ह साईन काढून टाकलं तर ते इक्वेशन अशा पद्धतीने होतं. हे इक्वेशन नंबर 4 जे आपल्याला देतं कोइफिशियंट ऑफ रेस्टिट्यूशन फॉर नॉन हेड ऑन कोलिजन. ते काढायचं असेल तर तुम्हाला त्यांच्या फायनल व्हेलॉसिटीज v1 v2, इनिशियल व्हेलॉसिटीज u1 u2 आणि हे चारही अँगल अल्फा 1 अल्फा 2 बीटा 1 बीटा 2 माहिती असली पाहिजे. हे तीन इक्वेशन्स 1 2 3 and this 4, all these 4 equations can be used to find out their velocities after collision, coefficient of restitution, etc. Thank you for watching.